In section 1.2, we will learn about truth tables. They're just tools like training wheels to help you understand what happens when we put all of the logical connectives that we learned in section 1.1. So to review, these here are our logical connectives, or, and not. Truth tables go from left to right and top down. So to start off, P and Q represent statements, and these statements can only be true or false. So in the columns labeled P and Q, we're going to list all the possible true and false combinations of P and Q. So now we have an exhaustive list of all the possible combinations. And then we're going to see what happens to the truth value of our overall statement in the last column. And as we'll see later on, these combinations can get pretty complicated, but going one step at a time makes things simple to understand. So in this first example, we have P or Q. So we have a true and a true. So in this case, our or is not exclusive. So because both of these are true, and we just need P or Q have to be true in order for the whole statement to be true, then this is going to be true. The next line, we have P is true and Q is false. So P or Q, because P is true, because P is true, then this overall statement, the or, is also going to be true. Again, we have a similar situation in the next one in which P is false and Q is true. So we can also have true in that one. But in the last column, both of P and Q are false. So P or Q, neither of them are true. So our overall statement is going to be false. Alrighty, now we're going to do the same thing for the second example. This time we have P and Q. So to review, in order for this whole statement P and Q to be true, both P and Q must be true. And we have that case in the first line. So P is true, Q is true. So P and Q is true. However, here we have P is true, Q is false. So P and Q is false. Again, we have P is false, Q is true. So P and Q is false because both of them aren't true. And now we have P is false, Q is false. None of them are true. So P and Q is going to be false. All right, so in the third example, we're going to apply negation, so not. So P can only be true or false. So when we negate it, we just list the opposite thing. So if P is true, then not P is going to be false. And if P is false, then not P is going to be true. So now we're going to combine all of our previous examples into a more complicated logical statement. So now we're going to make a truth table for not P or not Q. Okay, so again, we're just going to list our options just like we did before. So when you have a complicated statement like this, what you want to do is work from the inside out when you're making your columns. So what I like to do is I list P and Q first, because that's not going to change, and then I list anything that's attached to it. So this not is attached to this Q, so I'm going to do that as my next column. Then to get to the overall bigger statement, I'm going to move to P or not Q, which is in the parentheses. Then finally, I'm going to look at the overall statement, whatever this is, and then negate it. So again, we're working from the inside out. so not Q. So Q is true, so not Q is false. Q is false, so not Q is true. Q is true, so not Q is false. And Q is false, so not Q is true. Okay, so now we're going to look at the next column, which is P or not Q. So we're only going to look at the first column and the third column. So we have an or here, so recall what we did before in example number 1 of what happens when we have one true and then one false, or two truths or two falses. Okay, so looking at the first and the third column, we have a true and a false. So with our or, that's going to be true. In the second column, row, we have true, true. So P or Q or not Q is going to be true. In the third line, we have both of them are falses. So that's going to be false. And then last one, that's going to be true. Okay. Final step, we're going to negate whatever was in the previous column in order to get our overall statement, our final statement here. So we have a true, which I'm going to negate it to get a false. We have a true, so we get a false. False becomes true, and true becomes false. So there you go. That is the truth table for our statement in number 4. Okay, so now this is going to be our complicated example. We're going to make a truth table for this long statement. So you might notice that this time we have 3 variables. We have P, Q, and R. You might think, what are the possible combinations that I can make in order to make sure that my list is exhaustive? Well, here's a hint. If you have n number of variables, the number of rows that you'll need of your combinations is going to be 2 to the n. So notice how before we had only 2 variables, P and Q, so 2 to the 2 is 4, so we had 4 rows listed here. Now that we have 3 variables, we're going to do 2 to the n, in which n is equal to 3, so 2 to the 3 is equal to 8. So you're going to have 8 number of rows here. So now here's a mental shortcut to know that your list is going to list all the options. So for the first column, P, you're going to list the first half of the options as true and the last half of the options as false. So I'm going to have 4 truths and 4 falses. For the second column, you're going to have alternating pairs of true and falses. So we're going to have a pair of truths, then a pair of falses, pair of truths, and then a pair of falses. And then the last column is alternating at each step. So it's going to be true, false, true, false. Okay, so now we get into building our statement. So what I like to do is just get any negation out the way. So that's why I have this not P column. And then I just kind of go from left to right from there. So, okay. So to negate not P, we're just going to negate our first column. Okay, so now we have P or Q, which is our first part of the statement here. So P or Q is the exact same thing that we had before, just to remind you, in number 1. Okay, P or Q. So P or Q. Alrighty. Now we're going to look at not P or R. So not P or R. We're going to look at these 2 columns here. So we have a true and a false, which is true, false and a false, false, false and a false is false. two truths, true. Okay, now the last step is to combine these last two columns that we just did into our final statement. So notice how this time it's an and. So again, both parts here must be true in order for our overall statement to be true. So you have a true and a true, true, true and a false, nope, false, true and a true, true and a false, true and a true, true and a true, false, false. So now I hope that you have a better understanding of how to use truth tables and find logically equivalent statements.